problem number 21 is asking us to use synthetic division in order to simplify this expression. So remember, synthetic division means make the denominator, what would make the denominator equal 0, right? If we set this equal to 0, we'd have a 2. So 2 is my outside value, right? And then I'm going to set up the synthetic division symbol, and I'm going to put each of the values for the coefficients for each of the terms in my numerator on the inside. So x cubed has a 1 in front of it. I do not have an x squared, so I need to put a 0 in, so don't forget about that. And then x to the first has a negative 12, and my constant has a 16. So I'm going to start off by bringing down the 1, and then I'm going to multiply. 2 times 1 is 2. I'm going to add, which makes this 2. Multiply again, which means I get a 4. Add again, which means I get negative 8, and then I'm going to multiply and I'm going to get negative 16, and this last value is my remainder, which for us is 0. So if they ask for the solution now, I'm going to say this is my coefficient, so minus 8. The 2 would be x to the first, and then this would be the coefficient of x squared, so it's going to look like x squared minus 2x minus 8, no remainder. Problem 23, it says find the average rate of change over the given interval. And so this is where we're going to plug in, use our slope formula, y2 minus y1 over, well, here's my x2 and x1, negative 3 minus 2. And then to get the y values, I'm going to take a look at this graph, and I'm going to say at negative 3, the y value is 2. Okay, and they're going to say at 2, my y value is 1. So this looks like 1 over negative 5. And then I can do the same thing over here. My x values go on the bottom. So I'm going to say negative 1 minus 4. And then if I go to negative 1, it looks like my output is negative 3. And if I go to 4, my output is negative 1. So be careful, you're subtracting negative 1. So it looks like negative 2 over negative 5, which I can simplify, make that positive, and say 2/5. So 2/5 would be the average rate of change over the interval from negative 1 to positive 4. Alright, inverse functions, problem 26. So I'm not going to do all of these because they're all very similar, but the idea is let's switch x and y. So this is x, and remember f of x really means the same thing as y. So if I switch x and y, my problem becomes x equals 1/3 y plus 2. And now I need to resolve this and get x or get y alone again. So I'm going to subtract the 2 over, minus 2 on both sides. It equals 1/3 y. And then to get rid of a 1/3, I'm going to multiply both sides by 3. And I'm going to get 3x minus 6 is equal to y. So I would say the inverse of f of x is this, which remember sometimes the notation instead of writing y, use the too big of eraser, okay, instead of writing y, let's try that one more time, okay, let's do this the easy way. Instead of using y, I'm going to write f inverse of x, and it does the same thing, right? So that little negative 1 means the same thing as the inverse of f, right? So the other problems are going to work out the same. We'll do one more. So instead of this, I'm going to write y, and I'm going to switch x and y, and it's going to say x equals y plus 3 over 4, and I need to get y alone. So I'm going to multiply 4 on both sides, and it's going to say 4x equals y plus 3. Subtract the 3 on both sides, and I'm going to get 4x minus 3 is equal to y, which again we can write as f inverse of x. Instead of writing the y, I can say the inverse of f is 4x minus 3. Right? So the last one's going to work out very similar to this one, right? So we won't go through that. Problem 27 is asking us to do composition. So this symbol right here, remember, open circle means to compose, and what compose means is, in this problem they're asking us to take the g function x plus 2 and go to the f function and plug in. So in both of these spots here, right, I'm going to plug in the the g function. So this is going to look like x plus 2 squared plus 5 times x plus 2 plus 6. So be careful again, don't just square the parts of f plus 2. We're going to square the whole thing, which is x squared plus 4x plus 4 plus 5x plus 10, just distributing, plus 6. Okay? So if I put all this together, it looks like x squared plus 9x, and I get 4 and 10 is 14, 14 and 6 is 20. So I would say this is the answer, the composition. Letter B is asking us to do the same thing, except we're not plugging into h. We're plugging into the inverse of h. So the first thing I need to do is find the inverse of h, which we just did. So this shouldn't be that challenging. So we're going to add 1 to both sides. It's going to be x plus 1 equals 4y. Divide both sides by 4, and I get x plus 1 over 4 is equal to y. So this is h inverse, my x plus 1 over 4. I'm going to plug g into this, which is really just in that one spot. So I'm going to say this is really x plus 2 plus 1 over 4, and this is equal to this entire expression, right? So we're going to say if I simplify this, this is really h inverse composed with g now, right? The whole thing. So this is really just x plus 3 on the top and 4 on the bottom, and this is h inverse composed with g, okay? And that would be my final answer. So next problem. Problem 29. It's saying at what point do these graphs intersect each other? We've seen this several times. This really just means set them equal to each other and solve. So I'm going to say 2x squared minus 5x minus 12 is equal to negative x plus 4. So I just need to set this equal to 0, which means add the x over, subtract the 4 over, and I will get 2x squared minus 4x. And when I subtract a 4 on both sides, I'll get minus 16. And now it equals 0 because I've gotten rid of all of the elements on the right-hand side. So I can now simplify this a little bit. All of the expressions have a 2 in them, so I can divide them away, and it'll become x squared minus 2x minus 8 equals 0. And I can factor this. This is x minus 4 and x plus 2 equals 0. So I get two x values. X equals 4 and x equals negative 2. We just need to be careful. They didn't say at what x values. They said at what points, right? Points are made up of an x and a y. And so I need to take these x's and I can plug them into either of these functions, because what you'll find is if you try both of them, they'll both give you the same answer. If I plug in, I'm just going to use this simple one. If I plug in a 4 here, it's going to say negative 4 plus 4. Well, that's 0. So when I plug in a 4 into the g function, I get back a y value of 0. So I'm going to say 4, 0 is one of the points where the graphs intersect. And when I plug in a negative 2, I get negative 2 plus 4. Well, that's 2. So when I plug in a negative 2, I get back a 2. And so I'm going to say the other point where they intersect is at negative 2, comma 2. All right, moving along. It's saying a man throws a ball from a height of 7 feet and an initial velocity of 54 feet per second, and they're giving us a formula for it's called the velocity model, right? And so they're asking us some questions after we do that. So let's start off with writing the equation that we're going to use to answer these questions. Our velocity is v0, v sub 0. So I'm going to say h of t, okay, which remember this is the height at some time, is negative 16t squared plus 54 is my v sub 0, 54t, plus, and my s sub 0 is my initial height, which is 7. Okay, so here's what they're saying in this problem. Let's kind of draw ourselves a picture. There's somebody standing on the ground, and he's throwing a ball, and it's going like that, and it's hitting the ground. Right, so he's not throwing it from the ground. He's throwing it, he's maybe standing here, right, and he's throwing it from his hand. That's my excellent stick figure man, right? He's throwing it from his hand, so it's a little bit far off the ground. All right, so we're kind of looking at this picture, and we're wondering, first of all, how long does it take him to hit the ground? Well, the ground is over here, and if I say, what is the height of the ball when it hits the ground, the answer is it says a height of 0. So that's going to be my h value. We're saying a height at some time, so we're going to say for letter A, 0 equals negative 16t squared plus 54t plus 7. So if I'm solving this problem for t, because they asked about how long is a time. So we're actually just trying to find time here. So I'm going to use the quadratic formula. I would not want to try to factor this or try to use completing the square. Those are more work than we need to do. So I'm going to use the quadratic formula. Negative 54 plus or minus the square root of 54 squared, which is b squared, minus 4 times negative 16 times 7, okay, that's 4ac, all over 2 times negative 16. So this is what t equals. Because remember, it's usually x equals, but we replaced our x's with t's. So I need to simplify. Negative 54 plus or minus, I know the denominator is going to become negative 32. And so underneath my radical, I'm just going to simplify just that part. So if I do 54 squared, okay, I get 29/16, and I'm going to subtract from that 4 times negative 16 times negative 9, and it looks like I get 2340 as my final answer. 2340. Okay, so again, this would be a problem where I might have to use my calculator to do the square root of 2340. Let's check and see if that's perfect square. It's not. It's about 48.4. All right, let me double check my work here. 54 squared. Okay, I don't know if this comes out correctly. I'm using the simple calculator. Minus 4 times 16 times 9. Yep, 2340. Okay, so when I square root 2340, I get not a nice number. It's about 48.4. So I'm going to say this is really negative 54 plus or minus, if I take the square root of 2340, 48.4, okay, all over negative 32. And so I have two possibilities. I have to do negative 54, negative 54, typing on my calculator, negative 54 plus 48.4, which is negative 5.6, and then negative 5.6 divided by negative 32 is a positive 0.175. Okay, so I'm going to say x equals 0.175. Right, my other possibility is that it's negative 54 minus 48.4. So let's do that. 54 minus minus 48.4 is negative 102.4, and then I'm going to divide that by negative 32, and I'm going to get 3.2. X equals 3.2. Right, and so if I check this problem, this first value would be how long it took kind of right here, right? And the second one, the longer one, is how long it took to hit the ground. So I'm going to go with this one and say 3.2 seconds would be the amount of time it took to hit the ground on the other side. Okay, so now I can answer my second question. What was the maximum height of the ball? So I'm going to get rid of all this information so we have some space to work with. Right? So we're going to say, what was the maximum height of the ball? Well, maximum is the key word here. Maximum means vertex. Right? So I'm going to use this same function, okay, and I'm going to find the vertex of the function and say, well, the vertex is negative b over 2a, and that's going to help me find t. So that would be for us negative 54 over 2 times negative 16, and so that's really 54 over 32. 54 divided by 32 is 1.6875, and so that would be the amount of time, the seconds, that it took to get to the maximum height. But here's the thing. I don't actually care about the time. They didn't ask how long did it take to get to the maximum height. They said, what is the maximum height? So I need to take this value and plug it back in for t and find out what comes out. So we're going to actually do h of 1.6875. I'm not going to round, right? Because we're going to try to get the most exact answer. So this would be 16 times 1.6875 squared plus 54 times 1.6875 again, okay, plus 7. Okay, so let's type this in. So if I do 1.6875 squared, okay, we got to do order of operations, which says square first, okay, and then I multiply by negative 16, okay, I get negative 45.5625, right, and then the second part of my problem, it says 54, okay, times 1.6875. Okay, so I'm just simplifying in parts here. This says plus 91.125 plus 7. So I'm going to put this together. This says 91.125 plus negative 45.5625 plus 7. And that looks like 52.5625. So I'm going to say the height at its maximum was 52.5625, and I need a units. If you notice, they're talking about feet and feet in my problem, so this is 52 feet tall. Okay, so that was the maximum height. So the last problem I'm not going to do, and the reason that I'm not going to do it is because it solves exactly like letter A. Letter A, the height of the ball was 0, and so I plugged in a 0. And in letter C, it's 25 feet. So the only difference is I'm going to plug in a 25 here, and then solve it for 0. And then just go through the exact same quadratic formula, just like we did for problem letter A. Right, so it's going to be a repetition, so I'm not going to do that particular problem. Right, so that's the end of the first page. Right, 32 is exactly the same as 31, so I'm not going to do that one again. So we'll finish off problem 33 in the last video, and we'll go from 33 down to 40 to the end of the last page and the end of your final exam review.